Hi students, welcome to session 3 of changes around us. So students, in the previous session we discussed about various changes like physical and chemical changes, irreversible and reversible changes. So we are done with all the types of changes, but still there is something to discuss about in this lesson, and it is very important. So in today's session we will learn about expansion and contraction of materials. So now let us start with today's session and learn something about expansion and contraction. Yes, students, as we know that different materials expand or contract at different rates. In general, gases expand more than liquids and liquids expand more than solids. Like, we can say that heat is a form of energy, and when a substance is heated, it gains energy and changes occur in it. So these changes can be of many types, like change in the size of an object on heating. So what happens when we heat any object? Right, expansion. So expansion takes place on heating of any object. And so we can say that increase in size of an object takes place. Expansion, and the object is said to have expanded. Expansion can take place in all the three states of matter, that is, solid, liquid and gases. And what is contraction? Contraction means decrease in size of an object, which actually happens on cooling of an object. So this is the basic difference between expansion and contraction. So expansion always deals with the increase in size of an object, and contraction always deals with the decrease in size of an object. And contraction can also take place in all the three states of matter, that is in solids, in liquids, as well as in gases. Even the change in hardness of objects also take place. So now let us discuss about the expansion and contraction which takes place in all the three states of matter. But before that, I want to share one interesting and very knowledgeable thing with you. Yes, it is about James Prescott Joule. James Prescott Joule was a very knowledgeable scientist who was born in 1818 and died in 1889. He actually studied the nature of heat and he discovered its relationship to mechanical work. And so he defined the unit of work as joule. Obviously, he named it after him. So he studied the nature of heat. But what is the relevance with our expansion and contraction of materials of this James Prescott Joule? Yes, it is relevant, as we discussed about heating. Like heating water can change it to steam. Thus heating a material can change it. Water changes to ice on cooling, thus by cooling a material can also change. But the effect of heating is opposite to that of cooling. And so we can say that heating a substance can make it expand, but the amount of expansion differs in solids, liquids, and gases. And so, Joule was the one who studied the nature of heat and discovered its relationship to the mechanical work. And so, it was concluded that gases expand the most while solids expand the least. So, remember this important point. Now, let us discuss about the first state of matter in which expansion and contraction takes place. So, students, basically in solids, most of the solids expand on heating, but on cooling, they come back to their original size, like iron tools which are fitted in their wooden handles by heating. Like on heating, the tools expand, the wooden handles fixes itself or easily inside the ring but tightly. Like in railway tracks, the space is left between two rails at the joint. And the small gaps, the railway tracks consist of two parallel metal rails which are joined together. And they have small gaps known as expansion gaps. So why they are called as expansion gaps? Because deliberately the space or the gap is left between the rails as there is an expansion of the rails in hot weather. And that is why we can say that expansion takes place in solids. So, in railway tracks, the space is left between two rails at the joint, and this is done to allow the expansion of iron rails during summers. Even many solid objects on heating become soft. This is how a blacksmith makes the tools of iron. On heating till red hot, iron becomes soft and it can be easily beaten into any shape. Like solids can turn into liquids and liquids can turn into gases on heating. So we can say that expansion has taken place in solids. In the same way, there are some other examples in which we can discuss expansion and contraction. Like people who design structures such as buildings and bridges are very careful about the materials they use. Like they choose the materials that will not break when temperatures change. So we can say that a building project often requires two or more materials. So architects should not choose materials that expand and contract in different ways in different seasons. They should keep in mind that what material to be used or what material is to be used, because one material might expand faster than another material. And if this happens, there could be a damage to the structure. So think about the solid materials you use or see every day. If you cannot think, then here are a few examples of solids that expand and contract. And they are like metal lids on jars, then hot water pipes in homes, like metal frames around windows, railroads which we discussed, and car engines. So these are some of the examples. What will happen if these materials were damaged? Now you may think that a tooth does not change, but teeth can expand and contract like other materials. When you have a cavity, the dentist removes the decayed part and fills it in. Like some scientists work on making new filling materials and they want these fillings to expand and contract just like our real teeth. So these are some of the examples of expansion in solids. Even the engineers use steel rods to make concrete bridges and buildings stronger, because the rods help support the concrete. So steel needs to expand and contract in the same way that the concrete does. And so, if the steel does not expand at the same rate as the concrete can crack and eventually the building could fall. Even the bridges and sidewalks are built in sections, and there are spaces between the sections called as expansion joints. Like we discussed in railway tracks, they consist of two parallel metal rails joined together, which are known as expansion gaps. In the same way, in bridges and sidewalks, there are spaces between the sections called as expansion joints. And so these expansion joints allow steel and concrete to expand without cracking. And so we can say that expansion joints narrow when bridge segments expand in hot weather, and expansion joints in a bridge separate when the side-by-side segments of a bridge contract in cold weather. So in this way, this expansion and contraction takes place. Even if we hold a very hot glass tumbler under cold water, it cracks. This is because the outer surface of the glass comes in a direct contact with cold water, and it contracts more as compared to the inner surface. And that is why contraction takes place in solids. So in this way, expansion in solids and expansion and contraction in solids take place. Now, let us discuss about the other state of matter, that is expansion and contraction of liquids. Now, what happens in liquids? Yes, this is a fact that liquids generally expand by larger amounts than solids, and this difference in expansion rate is sometimes observed when the gas tank of a car is filled on a hot day. So, just think about the liquid materials you use or see every day. There are a few of examples of liquids that expand and contract, like alcohol or mercury in thermometers, in gasoline in cars, even oceans and lakes, and engine coolant. So, these are some of the examples of liquids that expand and contract. Now, what would happen if these materials did not expand and contract as they are meant to? Students, you will be amazed to know that in the last 100 years, the temperatures of oceans and lakes on Earth has increased. Like, warmer oceans and lakes have a greater volume of water. When oceans have larger volumes, sea levels rise. And if there is enough of an increase in the volume, then coastal cities can flood. And so we should take care of it. The other examples like gasoline, which expands during hot weather, a full tank on a weathery day or a summer day could overflow. The liquid in a thermometer expands and contracts as the air becomes warmer or cooler. Even water expands on heating. You can try this with the help of an adult. Like, you can take a glass filled with water to its brim, and you can pour the water into a container and you can heat it, but do not boil it. And then you can try it to pour the water back into the same glass. The water overflows. This is because of the expansion which has taken place in liquids. Even a contraction also takes place in liquids. Like we have already observed that or we have already discussed that water expands on heating. So can you say what will happen if the water is allowed to cool down and then it is poured back into the glass? Will it still overflow? No, it will not overflow. This is because of the contraction which has taken place in water or in liquids. So this was all about expansion and contraction which takes place in liquids. Now, let us discuss about expansion and contraction of gases. Yes, students, gases that are heated expand in their containers. And so the energy of the gas particles increase by heating, by the process of heating. So what will happen if we will heat? Yes, the particles of warm gases hit the walls of the container and they hit it harder. So what will happen? If the walls of the container are flexible, the walls expand. And if the walls of the container are not flexible and cannot expand, then the pressure inside the container increases. And this way, the expansion and contraction takes place in gases, in case of gases. Now think about the gases you use or see every day. Yes, a few examples of gases that expand and contract are like air in balloons, air in tires, air in an air mattress, then air in a football, volleyball, basketball, etc. So, even the helium gas in a balloon expands when we move a balloon from a cold outdoors to a warm room. Even the sports balls such as footballs are also filled with air. And if we leave a football out in the cold, the air inside the balloon or air inside the ball will contract. And the ball will get soft and it will become unusable. So, always remember that in case of gases at a very low temperature, the average kinetic energy means motion. The kinetic energy of the particles in the balloon, if we take a balloon, in a balloon it will be very low and the particles do not collide as often with the walls of the balloon and it hit the walls with less force. It will hit the walls. So the balloon contracts. In the same way, in case of gases, if we take balloon, as the temperature of the gas inside the balloon rises, the particles will move faster and it will hit the wall of the balloon more often. So the balloon expands. So what would happen if those materials did not expand and contract as they are meant to? Yes. What can happen? Yes, when cars and bicycles travel, their tires rub on the road and this makes the tires get hot. And the air inside the tires will expand. If the tires are too full, they could burst. And if the tires are not too full, then they will contract. Like if you keep an inflated balloon in the sun for some time, what will happen? It will grow in size as the air inside it expands on taking heat from the surroundings. So this is the expansion which takes place in gases. And if an inflated balloon is tied at the mouth of a bottle and the bottle is placed in ice cold water, the balloon will shrink in size as the air inside the balloon contracts on cooling. Right? So, this is all about expansion and contraction in gases. And now, we will discuss about the application of expansion and contraction. So, what are the applications of expansion and contraction? Yes, the first one is about water. And this is a fact, a very interesting fact. So listen it carefully, that water has a very unique property. Like it contracts on cooling until it reaches the temperature of 4 degrees Celsius. However, when it is cooled further from 4 degrees Celsius to 0 degrees Celsius, it expands. So remember that water on cooling will contract and water on heating will expand. Is it so? No, it is not so. Because it has a unique property. When it reaches to 4 degrees Celsius, it contracts on cooling. And when it is cooled from 4 degrees Celsius to 0 degrees Celsius, it expands. And that is why ice floats on water. So normally the substances heat, when they are heated, they expand, and when they are cooled or cooled down, they contract. But here it is another case. Water on heating will not expand, but it will contract, and on cooling it will expand. And that is why ice floats on water. So this is about water. Even expansion by heating can be used in several everyday activities, like the jammed metal lid of a jar can be opened by heating. As we can use the jar, like we can invert it, the jar is inverted first and just the lid is dipped in hot water. So what happens after some time, the lid can be opened easily and the lid gets slightly expanded. So this is one such example or one such application of expansion and contraction. There is another application also, like how do mechanics fix tires around the wheels of cars? Let us see. Yes, the rubber tires used are slightly smaller in diameter than the wheels. And so the tires are heated so that they expand. And when they become slightly bigger, they can be easily slipped onto the wheels. And when the tires cool, they contract back to their original size and they press tightly onto the wheels and cannot come off. So, in this way, there are many or several everyday activities by which we can apply this science. These are some of the applications of expansion and contraction. So we discussed about expansion and contraction in some more detail. So now let us revise it again. Let us revise about expansion and somewhat about contraction, which takes place generally and in all the states of matter. Yes, different materials expand or contract at different rates. In general, gases expand more than liquids and liquids expand more than solids. So this can be observed in a solid object, in liquid as well as in gases too. So there are several everyday examples like the sag and outdoor electrical lines. It is much larger on hot summer days than it is on cold winter days. Even the rails for trains are installed during warm weather and have small gaps between the ends to allow for further expansion during very hot summer days. Even the metal expands more when a glass or a metal lid on a glass container can be loosened by running it into hot water. So because the metal expands more, a stuck metal lid on a glass container can be loosened by running hot water over the joint between the lid and the container, the expansion process, which we discussed right now. So liquids generally expand by larger amounts than solids, as we discussed. This difference in expansion rate is sometimes observed when the gas tank of the car is filled on a hot day. And if gasoline, which is pumped from the underground container, is cold and it gradually gets heated to a temperature of the car as it flows into the gas tank. So the gasoline expands in the volume faster than the gas tank and it overflows onto the ground. Even gases expand more than liquids when heated. The expansion difference between a gas and a solid can be observed by filling a plastic air mattress in a cool room and then using it on a hot beach. The difference in thermal expansion between the container and the gas could unexpectedly overinflate the mattress and it can blow a hole in the plastic. So sometimes man's ingenuity has led him to find practical applications, and these differences in thermal expansion between different materials have taken place. Like in other cases, man has developed technologies or applications that overcome the problems caused by the difference in thermal expansion between different materials. And the thermally induced change in the length of a thin strip of metal differs for each material. For example, when heated, a strip of steel would expand by half as much as an equal length piece of aluminium. And welding together a thin piece of each of these materials produces a bimetallic strip. So the difference in expansion causes the metal also to be changed when the temperature is changed. And this movement has many common uses, including oven thermometers to measure temperature, switches to regulate toasters or sandwich makers, and some practical applications or practical solutions to everyday thermal expansion problems in solids are like the material developed for filling teeth has the same expansion as the natural enamel of the tooth. Enamel means the protective covering of our tooth. Even the steel developed to reinforce concrete has the same expansion as the concrete. Even the concrete roads are poured with expansion joints between the slabs to allow for thermal expansion. And these are the joints which are the cause of the thumping noise commonly experienced when traveling on a concrete highway. Even the manufacture of mercury and alcohol thermometers is based upon the expansion difference between solids and liquids, because thermometer fabrication consists of capturing the small amount of liquid inside an empty tube which is made up of glass or clear plastic. So this is how expansion and contraction takes place, and we can apply it or we can use it in several activities, several everyday activities, right? So I hope you enjoyed today's session and learned about expansion and contraction in a very fine way. So I hope you enjoyed and you will enjoy other sessions too. So we will meet in the next session. Till then, keep enjoying and keep applying this science in your everyday life. It will be very helpful, right? So have a nice day, have a nice time. Till then, keep learning, keep enjoying. We'll meet in the next session. Bye-bye.